And so because we're going to be converting through different units, not only this unit in unit 6, but also unit 7 and 8, we'll also be doing this like pretty a lot throughout the rest of the semester. This is going to reoccur a lot. And so we learn this technique, and it's called dimensional analysis. And dimensional analysis it's basically a technique that you can use not just in chemistry. If you take other science classes like physics, engineering, you'll usually use it in there, and even like math, and you can use it in everyday life, as we're going to see when we go through some information here in just a little bit. So I'm going to go ahead and share my screen really quick, switch over to our Canvas. So for today, you have kind of your interactive notes for dimensional analysis, and then your assignment today is I'm kind of calling it an at-home lab, because you're going to be doing it at home, and you just need kind of a few things to help you measure. If you don't have them, then you can use, there's a measuring app on your phones that you can use in place of that. But if you have actual things like an actual measuring tape or timers, things like that, that'd be most beneficial. But I'm going to go ahead and click on here. And so let me get it to pop up. Okay, so dimensional analysis is a way, like I said, that we convert between units. So what we're going to be doing today is we're going to be converting between like some metric units and some imperial units. Imperial is what we use here in the United States, like feet, inches, pounds, ounces, gallons, all that kind of stuff. Metric units are going to be what the whole rest of the world uses, other than the United States and a couple of other really tiny countries that most people have not heard of. Okay. So the metric system is what the whole rest of the world uses, and that's where you see things like meters, kilometers, centimeters, millimeters for length and distance. And then we see things like grams or kilograms for mass and weight. And for volume, we see like liters and milliliters. And then time is the one that really, that's kind of the same for everybody. Days, hours, minutes, seconds, all that kind of stuff. So we're starting off today just talking about using this process of dimensional analysis to do basic conversions with some of the units that you're going to see on here. Now, these are definitely not all of the possible conversion factors. There's tons of conversion factors. These are just some basic ones that are kind of common, that you use a lot. And so what it says here is that we're going to learn to convert between units using conversion factors like these, and using this process that I mentioned. It's called dimensional analysis. And like I said, this is just a method for setting up these conversion problems to solve them. So this is how you show your work and how you make sure that your stuff is set up correctly before you do your calculation. And we're going to use it all throughout this unit, and then unit 7 and unit 8. I don't think it's in unit 9 as much, but for the next several units for most of the rest of the semester, this is going to reoccur a lot. And then, as I said, if you take other science classes, like if you take AP or IB physics, you'll see it there. If you take IB chemistry, you'll see it there. If you take things like biology, not going to see it as much there, but it could be used for certain things. Like if you need to, talk about like the size of a cell or a virus, and you want to convert the units from, nanometers to meters or something. Okay, you could do it with that. But in a lot of science, engineering, physical science classes like physics, chemistry, and then things like engineering, this comes up a lot. And so this is something that you'll use kind of throughout other classes as well. Okay, so here is the method that we are going to use to solve conversion problems. Okay, these are math word problems, and so a lot of people have trouble setting them up because they're not sure, okay, what goes where? What do I start with? What am I doing? I don't know what's going on. And so this is sort of the method that we have kind of come up with, and it's got a little acronym, CUP. It's just spelled with a K instead of a C, okay? But what it means, the K stands for the known, and the known is the information you're given in the problem to start with. And that will always be a number that has a unit, okay? The U is the unknown. That is the unit that you're being asked to convert to. So the unknown will not have a number. It'll be a question mark because it's unknown. That's what we're solving for. That's what we are trying to figure out. And then the P stands for plan. And this is where you create kind of a map or a pathway that shows you how to go from the known to the unknown. So your plan always starts with the units of the known and it ends with the units of the unknown. And sometimes if it's easy, you just need one conversion factor. You can go straight from one unit to the next. If it's not as easy, it might be 2 or 3 steps in between. Okay. Yes, into the unknown. That's a good one, Mariah. I still have not seen that, by the way. I haven't had a chance to watch it yet. But so here's an example of one that would be multiple steps because it depends on your conversion factors. To figure out your plan, always look at your conversion factors. If there's a conversion factor that has the units of your known and the units of your unknown in it, then that's really easy. Your plan's going to be one step because you can go straight from one to the other. If there's not a conversion factor that has the units of your known and the units of your unknown, then look at kind of how you can connect them. So for example, if they wanted us to convert days to seconds, I know I'm going to start with days, I'm going to end with seconds, but there's no conversion factor to go straight from days to seconds, unless you're going to memorize how many seconds are in a day. And most people are not going to do that. But what we do know is we know how many hours are in a day. I know that there are 24 hours in equal to 1 day. So I can convert from days to hours. And then I know how many minutes are in an hour. So I can convert from hours to minutes using the conversion factor that 1 hour equals 60 minutes. And then I know how many seconds are in a minute. So then I can convert from minutes to seconds using the fact that I know 1 minute equals 60 seconds. So this plan has 3 steps. Each arrow represents a step in my plan. And each arrow or each step, that means that I have to have a conversion factor. So I'm going to have a conversion factor that connects days to hours and allows me to change that unit. Then I would have a conversion factor that connects hours to minutes. So I could change that unit. And then lastly, I would have a conversion factor that relates minutes and seconds so that I could convert that last step. So really, depending on what your known and your unknown is and what conversion factors you have to work with, your plan could be 1 step, 2 steps, 3 steps. I mean, there are some problems where it's like 5 or 6 steps. Okay, we're not necessarily going to have any that are that long, but just know that it could be 1, 2, 3, 4 steps. Okay, it just depends on what you're given to work with on your conversion factors. Okay. So there's an example problem on here, but I'm going to go ahead and now that we've gone over this the cup thing, I'm going to switch over to the iPad because I'm actually going to use a slightly, or actually not the iPad yet. I'm going to switch over to a presentation that I have to go through that's not in your notes. So, all right. Can you guys see? Oh, it's loading. All right, can y'all see the full screen? I just want to make sure before I start talking. Yes, okay, thank you. All right, so dimensional analysis is what we're covering today. Scientific notation, we're going to get into that next time as we start talking about what the mole is. But here's dimensional analysis. As I said, we're going to use it. It's a technique. It's a way, a method of converting numbers into different units without changing their value. And so, like I said, you can use it in a lot of different ways, baking and cooking, because if you ever cook or bake and you have to like have, you know, a quarter cup, but like you don't have the quarter cup measuring thing, you only have tablespoons, then you got to figure out, well, how many tablespoons would be equal to that quarter of a cup. Okay. So when you're converting things for recipes, you do this, you just do it in your head sometimes because you don't think about writing it out on paper because it's not as involved. If you ever travel to foreign countries, because guess what? Pretty much every country other than the United States does not use things like feet or inches or miles or gallons, okay? They use kilometers or kilometers, depending on how you want to pronounce it. So if you go to a foreign country and you're looking at the street sign and it's telling you that, you know, it's 5 kilometers to get somewhere, you have to kind of think about, well, what's that going to be equal to in miles, okay? Or if you go to fill up with gas, which most countries call petrol in Europe, like not gas. If you go to fill up, they're going to be in liters. They're not going to be in gallons. So here, when you fill up with gas, we pay per gallon. Well, they pay per liter because they use metric units. So traveling to foreign countries and also with money, because if you travel somewhere else, they're not going to use dollars. They're going to use whatever their currency is. And you would need to know how to convert because you need to know, well, what is their currency equal to in dollars, okay? And a lot of like I mentioned, building engineering, because there's a lot of units, a lot of measurements involved with those types of things like architecture, building engineering, and other sciences like physics and chemistry and things like that. And so what happens is what we're going to do is we're going to set up these problems. And when we're done, we're going to end up multiplying the given numbers are known by conversion factors in order to get the number to the desired units that we want. Okay. And so conversion factors, as we looked at on Canvas, they're ratios and they're equivalent values, meaning that they equal each other, they equal 1. Okay. And so we alter the number without changing its value. So for example, how many hours are in a day? Okay. 24 hours equals 1 day. Those things are equivalent. They're the same. So 24 hours equals 1 day equals 24 hours. So I can write it in a fraction form. And because they're equal, it's 1. Okay. So I can write 24 hours over 1 day. And because those are equivalent, that value, it's 1. And, or I could flip it. I could write the 1 day on top and the 24 hours on the bottom. Now, the reason that there's 2 versions is it's going to depend on our problem. If I'm starting with hours and trying to convert to days, then I'm going to use this one with hours on the bottom because I'm going to have to divide. If I'm starting with days and I'm trying to calculate the number of hours that's equal to, then I'm going to use this one because hours has to go on top and I'm going to have to multiply. And so knowing which way to flip your conversion factor is directly related to knowing what is your known and what is your unknown so that you can set up your problem correctly. So doing that cup method, you're going to have to do that on every problem because that's what's going to help you in the beginning to set up your problems. So again, both of them, like I said, they're useful. It just depends on which direction we're going. Are we going from hours to days or days to hours? And that's going to tell us the correct way that we need to flip it for the problem that we're trying to solve. Okay. All right, here's the second one. 12 inches equals 1 foot. That's a common conversion factor that you guys usually learn like in elementary school. Okay. So what are the 2 ways that I could write this one in the fraction form based on how we did the first one? What do you guys think? So I could put 12 inches on top and 1 foot on the bottom. That could be one version. Or I could flip it the other way and I could do 1 foot on top and 12 inches on the bottom. So either of those are valid ways to write it. It's just going to depend on how I need to turn it or flip it for the problem that I'm trying to solve. Okay. And that's where that cup comes in. All right. So what would the conversion factor be for days in a week? So 7 days equals 1 week. How would we write that one in that fraction form?
7/1.
So, and make sure, don't just do numbers. You have to have the units. So 7 days over 1 week, or what would the other way be?
Or 1 week and 7 days.
Yes. So, and I'm going to be very picky because there are when we do these problems with conversions and dimensional analysis throughout the whole rest of the semester, your units are the most important part. It's called dimensional analysis because the dimensional part is talking about the units. Those are the dimensions. That's how you're measuring. Okay. So we're analyzing the dimensions or we're analyzing the units and using those to convert and change. So we do not like naked numbers. So if you just write numbers, then that not only is that going to make you very, very, very confused because you're not going to know how to set up the problem, but also I'm going to tell you that you have naked numbers and that's not allowed. Okay. So the units are almost more important than the numbers. Okay. You need really both. They're like equally important. But if you just write numbers with no units when you're doing these types of problems, you're going to confuse yourself and you're going to get lost. And then you're going to be like, wait a minute, I don't know what to do. I don't know how to flip it. I don't know which way to do it. Okay. Do I multiply? Do I divide? So, all right. So steps to apply this in a real problem, similar to what we saw on Canvas. You write down the known, that's your starting number and units. You write down the unknown, which is just a unit. You can put a question mark with it. I like to put question mark and then the unit, so I know that's the unknown. Then you create your plan to go from the known to the unknown. Use your conversion factors as the guide for doing that because that's going to help you figure out how many steps it is. Once you figure out your plan, then you're going to draw this chart, and we're going to look at it here in a second. And what you're going to do is you're going to fill in conversion factors appropriately, And we want to make sure units cancel out. They have to be on opposite diagonal sides to cancel out. So one has to be on the top and one has to be diagonally opposite on the bottom to cancel out, okay? And then once you have your chart all set up correctly and your units cancel out and you have your conversion factors in correctly, then you multiply the numbers on top and you divide by numbers on the bottom in the calculator. Now you can do it either way. If you want to multiply all the way across the top and then divide by each number on the bottom, you can do that. I personally just like to go left to right. So if there's a number on the top and then the next one's on the bottom, then I'll divide, and then the next one's on top, then I'll multiply. It's up to you if you want to do all the multiplying first and then do all the dividing second, or if you just want to go left to right, you know, and alternate multiplying, dividing, or whatever you need to do. You should get the same answer as long as you're typing in the numbers correctly, because multiplication and division are the same step in PEMDAS, your order of operations. So it shouldn't matter if you do all the multiplying first and all the dividing second, or if you alternate them and just go left to right as you read the problem, okay? Okay, so we're gonna do a couple examples together. So this is our first example. How many seconds are in 1 year, okay? And I'm going to switch over to my iPad in just a second, so that we can do the cup method and work this out. All right, so I'm going to stop sharing. And switch over to the iPad. So that we can go through together and do all the steps so that you guys can see what you should be doing when you're doing this on your own. Okay, so I just kind of wrote, sorry, my handwriting's a little messy, but I just kind of rewrote the question. How many seconds are in 1 year? I just use the abbreviation. So if you abbreviate seconds, the actual abbreviation is just a lowercase s. It is not SEC. A lot of people like to put SEC as the abbreviation for seconds. That is not the actual abbreviation. The actual scientific abbreviation is just this lowercase letter s. So how many seconds are in 1 year? And year is just abbreviated YR. So I'm going to do first my known. So I'm going to do my known. I'm going to do my unknown. And then I'm going to put a P for the plan down here. Okay, so you always start off and you got to fill your cup. Okay, so until your cup is filled, you can't start your problem. Okay, so first part is always to fill our K, our known. So looking at this question, what do you guys think the known is going to be?
1 year.
1 year. Here it is right here. Okay. So remember, the known will always have a number and units. Okay. So I'm going to write 1 year here for my known. All right. So now, what do you think our unknown is in this question? What are we trying to solve for, or what are we trying to convert to?
Seconds.
Seconds. Okay, because remember, the unknown will not have a number, it will just have units. Okay. So let me go over here and write our, so I'm going to put question mark seconds. So now plan. Now I will tell you, your plan always starts with the units of your known. So always, I can go ahead and put year there. Now, do I know a conversion factor that allows me to go directly from year to seconds? Probably not. Okay. So on you have a list to refer to in Canvas of some possible conversion factors. And so this question's dealing with time because we have years and seconds. So you probably want to look at the section that has the conversion factors that are possible for time. And so we don't have one that has years and seconds equal to each other. Okay. What we do have, and I'm going to kind of write them out here because these are the ones that you have on Canvas. So you have 1 year equals 365 days. Technically, it should be 365.25 because technically a year has an extra quarter of a day. That's why every 4 years we have a leap year to make up for that day. 1 day is 24 hours. 1 hour is 60 minutes. And 1 minute is 60 seconds. Okay. All right. So these are the time conversion factors, the common ones that you guys have on Canvas. So I'm starting with year. So what do you guys think the first step in the plan is going to be to change from year to what?
Days.
Yep. I'm going to go from year to days. And the reason I know that is because there's a conversion factor right here that has years and days. Okay, so I'm starting with years, and the only conversion factor on here that has years is that one. So I'm going to go from years to days. Now I want the conversion factor that'll go from day to something else. So what are we going to change day to?
Hours.
Yep, here's days to hours. Okay, and then now I want something that has hours and something else. So I'm going to go from hours to what?
Minutes.
Minutes. And then I'm kind of out of room, so I'm going to extend this down a little bit, but I got to go from minutes to seconds. Okay. So I'm using all of these. Now, I will tell you, there's a shortcut if you know how many seconds are in an hour, because 1 hour equals 3,600 seconds. So depending on how you want to do this, you could save yourself a step. And instead of going from hours to minutes to seconds, you could go straight from hours to seconds by using this. And that way you save a step in your plan. Either way, if you do it the 5 steps or the 4 steps, or I'm sorry, the 4 steps or the 3 steps, you're going to get the same answer. Okay. So we'll just do the original one where we go from hours to minutes to seconds. Okay. But you could go straight from hours to seconds by using that other conversion factor. So what I want to kind of show you with that is that, like, there is more than one way to do some of these problems. Okay. There's more than one path. You just have to make sure you're using the conversion factors correctly with whichever path you choose. Okay. All right. So now that we have our plan, now we're going to do that part where you're going to set up this dimensional analysis chart. Some people call it a T-chart or railroad tracks or like fence posts. I don't call it any of that because you guys are not in elementary school. So I just call it the dimensional analysis setup or the dimensional analysis chart or dimensional analysis boxes, maybe. Okay. So when you set up these dimensional analysis boxes, okay, you're going to have kind of a horizontal line. And then every so often you're going to have a vertical line. I like to just do my first vertical line because I don't know how long my problem is going to be. So I don't know how many vertical lines I'm going to need. Now, if you've already done your plan, then I know that I'm going to have 1, 2, 3, 4 steps. Okay. So that gives you a little bit of a hint. This is going to be kind of a long problem. But depending on how big you write or how small you write, you might need more or less space. So I like to do my vertical lines as I go and not draw them all in at once. It's up to you. If you want to draw all of them in at once, that's at the beginning, that's fine. Just make sure that you have enough space to write your information in between. Okay. So you're going to do that setup. And then my known always goes in this first top box. So our known for this problem was 1 year. So I'm going to bring that down here. Now this bottom box, you don't ever write anything here. Because it's understood that it's like an imaginary 1 because we're just turning this into a fraction form. So it's like we're putting it over the number 1, but we don't write that there. Okay. So typically that bottom box is blank. Now you do have things called double conversions where you could have something down there. Like if I was doing speed and I had like miles per hour, I would have miles on the top and I would have hours on the bottom. And I can convert both units. I can convert it from like miles per hour to like meters per second. Okay. That's a little bit more complicated than what we're going to do, but you can have something on the bottom. But for our problems, most of the time, we're not going to have anything on the bottom of that first box. It's just going to stay empty. We're not going to write anything down there. Okay. So how you do this is you use your conversion factors. So I'm going to look at my plan. The first step that we have in our plan is to go from years to days. And we need to find the conversion factor that allows us to do that. Here it is. 1 year equals 365 days. So I need to turn that conversion factor into the fraction form like we saw on the notes. So remember, we can turn it two ways. I can write 1 year over 365 days, or I can write 365 days over 1 year. So how do I know which one is the correct one to use? What do you guys think? Anybody have an idea?
The first one, because you're trying to go to the year to 365 days.
Okay, so which one would I pick?
The first
one.
Okay, you think the first one? Okay, so you got to remember back to that last, or that I think it was step 4. I want to set it up so that units cancel out, so they have to be diagonally opposite of each other. So because of that, I'm actually going to use the second one. And the reason I'm using the second one is because I have to look up here at these units. I'm starting with years. So I need to put year down here so that year cancels out. So that's why I told you guys it's so important that you write your units and not just your numbers. Because if I had just written 1 up here and not 1 year, then I'd be like, well, I don't know how to put the conversion factor in the next box. Okay, how does it go? Does the year go on top or bottom? But because I have year written here, that's my guide. That tells me that year has to go down here, and that tells me that days has to go on top. And then I just plug in my numbers. So 1 is with year and 365 is with days. So that's the first step. So all I've done was I took the conversion factor for 1 year equals 365 days, and I turned it into the fraction form, and I'm choosing to use this one, okay, the one that's days on top, year on the bottom. And the reason that I'm choosing that one is because I always want to cancel my units diagonally opposite. So since my known up in that top first box started with year, that means I have to have year down here to cancel out. And that forces me to put 1 year on the bottom and then the 365 days in the numerator on top. So now we need another conversion factor because we're not solving for days, we're solving for seconds. So my next one in my plan, let's go back up to our plan here. My next step in the plan was to go from days to hours. That's my next arrow right here. And if we go up here and look, my conversion factor is 1 day equals 24 hours. Okay. So again, I can write the day on top and the hours on bottom, or I can do it the other way with the hours on top and the day on the bottom. Now, based on what we just looked at with the first conversion factor, which one do you guys think we're going to use for this one? So look at what's up here on top that we need to cancel out.
1 day over 24 hours.
Okay, so look what's here on top. What's here on top?
The right one. Since
I'm going to use this one. Okay, always look at what's on the top of your previous box that's not canceled out, because I'm trying to cancel that out. I'm trying to get rid of it. Just like here, I had year, and I put year down here so that it canceled out. Now I have days on top. That means that I have to put day down here and hours up here. And that means that I have to use this version. So the 1 day is on the bottom and the 24 hours is on top. So now I can slash through my days. Day and days cancel out. So now I have converted, or I've changed to hours. Now we go back up here and look at our next step. Our next step is hours to minutes. Okay, if we do the long plan, hours to minutes is the next one. And here's my conversion factor. 1 hour equals 60 minutes. So again, if I look at my fraction form, I can do this version, or I can flip it the other way. Okay, and so again, look at what is in this top box that I need to cancel. So up on top, I have 24 hours. So based on that, which of these would I use for the next box? 60 minutes on top and 1 hour on bottom, or 1 hour on top, 60 minutes on bottom?
60 minutes on top.
Yes. So I want to use this one because the hours on the bottom. And so again, going back to my, and so I'm going to extend my setup here. I'm going to put another vertical line here. And then let me erase this a little bit. All right. So we have, all right. So I want to put 1 hour down here because I want hours to cancel out. That means the 60 minutes have to go up on top. Okay. All right. So then there's one more step in this one. Our last step is to go minutes to seconds. And we know from up here, my conversion factor is 1 minute equals 60 seconds. So again, no, I didn't mean to do that. Uh-oh. Put our line back in here. Okay. So we know that we can do 1 minute over 60 seconds, or I can do 60 seconds over 1 minute. Oops. Okay. So looking at what's up here, we have minute on the last top box. So which version are we going to use of these two?
The second one.
The second one, because we want minute on the bottom so that it cancels. Now, I ran out of room, so I'm going to have to kind of continue on this next line. Okay, but I would have 1 minute down here and 60 seconds on top, and then this minute cancels with this minute, because really I would have this would be extended. I would keep going to the right. I just ran out of room because this is such a long problem, and I'm working on an iPad mini that's old, so I don't have as much space on the screen. But now I'm done, and I know that I'm done because the units that are here on this last top box are seconds, and that is our unknown. Okay, so when you're done, the units that are on the top of your last box, they will be the units for the unknown. That's how you know you're done with all your steps. Okay, and I've used all the steps in my plan. I've done years to days, days to hours, hours to minutes, minutes to seconds. Okay, so now that the units that are on top are the unknown units, that means I'm done. I don't want to cancel anymore because I've gotten to where I want to. This is now where you need your calculator to do your math. Okay. What you will do, any numbers on the top, you multiply. This is kind of like a big long fraction. Anything that's on the top in the numerator gets multiplied. Anything that's on the bottom in the denominator gets divided. Okay. So on this problem, I would do in my calculator, and I'm going to write it out. You don't have to write what I'm about to write like on your work. Okay. I'm just writing it out so that you guys can see how you would do it in the calculator. But I would have 1 times 365, because 365 here is in the numerator. The bottom here, there's a 1. Anywhere you have ones, you don't need to type them in the calculator, because what happens if you multiply or divide by 1? Does your number change?
No.
No. Okay. So the ones are in our setup to show that the units are canceling. So we have to have them in our setup to show everything properly canceling. But in your calculator, don't type the ones. Okay. Now I have to type this first one because that's the known. But all the ones that are part of conversion factors, don't type them, because the more you type in the calculator, the more chance there is that you type something wrong and you get something messed up in your calculation. Okay. So anywhere there's ones, you can just ignore them when you're typing stuff in the calculator. You don't need to multiply or divide by 1. So in this problem, everything is actually going to be multiplication, because on the bottom, we have ones on every conversion factor on the bottom. 1 year, 1 day, 1 hour, 1 minute. Okay. So this problem is actually all multiplication. So I have 1 times 365 times 24 times 60 times another 60. Kind of ran out of room. Sorry. So this is where you need your calculator. Now, some stuff you'll be able to do just on the calculator, like on your phone. But I will say as we go through this unit, you are going to need a calculator that can type scientific notation, which is usually a scientific calculator. So you have the one that I've already linked to on Canvas on our homepage. And then in today's lesson, I also linked you to the Google calculator. Both of those can do scientific notation, the functions that we need. If you really want to get a calculator, the ones that I usually have you guys use in class are really good, and they're only like $10 to $15 depending on where you go. But I'm going to do, okay, 1 times 365 times 24 times 60 times 60. Okay. And I get a really big number. I get, let's see, 3153600. So that's 1, 2, 3. So we get 31,536,000 seconds. That's the answer. Now, that's a really big number. I would actually change that number to scientific notation, but we haven't learned scientific notation yet, so I'm not going to. But if I wanted to change that number to scientific notation, just to give you guys a preview of what's coming next time, my number, I could rewrite it 3.1536 times 10 to the, let's see, 1, 2, 3, 4, 5, 6, 10 to the 7th seconds. All I did was move the decimal from where it is at the end. I moved it 7 times. That's where that exponent comes from. So next time, that's what we're going to be talking about, is dealing with really big and really small numbers and how we write them. And it's this method called scientific notation. All right, I'm going to switch back over. And so here's, you can see, here's the work. Oh, no, you can't see. I got to share screen again. Sorry, guys. All right, so let's switch back over to our presentation. All right, so now here you can see, here's the example worked out. Everything kind of cancels just like we had. So this is what it would look like. I told you guys I ran out of room, so I had to write this last conversion factor kind of on the next line. But really, it should look like this. Okay, so make sure you space it so where you have enough space to do it like this all on one line. And how all my units cancel except for seconds, which is what we wanted to solve for our unknown. And then here is my correct answer. Okay, so go back to presentation mode. Go through all these steps because there's just walking us through the steps that we went through. Okay, so we're going to do another one. How many feet are in 250.4 centimeters? Okay, 250.4 centimeters. So this one is dealing with length. The other one was time. This one's length. You could have mass, okay? You could have volume. You could have all kinds of stuff. You can even do stuff where you say, you know, like you're having a party and you need to know how many, you know, how much it's going to cost to feed a certain number of people. And you know that it costs, you know, so much per plate of food or so much per slice of cake or whatever. And so you can actually figure out, you know, how much is it going to cost you to feed 50 people, you know, a dinner and dessert or something like that. So it doesn't just have to be measurements. You can do it for other stuff too. Okay, so how many feet are in 250.4 centimeters? So this one, I'm going to do my known. What do you guys think the known is in this one?
250.4 centimeters.
Exactly, 250.4 centimeters. And what is my unknown?
Feet.
Feet, question mark feet. Okay, so we're going from centimeters to feet. Now, there is, I will tell you, there's not really a conversion factor to go straight from centimeters to feet. If you look at what you're given in the lesson on Canvas, okay, I'm going to start with centimeters. There is a conversion factor that goes from centimeters to inches, okay? It's in your it's on that handout, or not handout, but that chart in your notes. 1 inch equals 2.54 centimeters. So that connects me from centimeters to inches. And then you guys should know, because I can go from inches to feet, what's the conversion factor between inches and feet? Because that's a common one.
12 inches equals 1 foot.
Yep, 12 inches equals 1 foot. So this one is only going to be a 2-step problem, because I'm going to need one conversion factor to go from centimeters to inches, and then a second conversion factor to go from inches to feet. Okay. So when I go to set up my problem, I'm going to start with my known. So 250.4 centimeters. I'm going to draw my setup here. Now, the first step is here, centimeters to inches. So I need this conversion factor. This is the one that has centimeters and inches both in it. So how am I going to write it? Am I going to put 1 inch on bottom and 2.54 centimeters on top? Or am I going to put 2.54 centimeters on bottom and 1 inch on top?
250.4 on the bottom.
Yes. So again, let your units be the guide. I have centimeters up here. That means I have to put centimeters down here, and I have to put inches up here. And then the numbers just go with them. So the 2.54 centimeters goes down here. The 1 goes up here with the inch. And centimeters now cancels out. Okay. Then for my second step, now I'm going inches to feet. So I'm going to use this conversion factor that connects inches and feet together. So now in this one, do I do 12 inches on bottom and 1 foot on top, or do I do 1 foot on bottom and 12 inches on top? What do we think?
1 foot on top and 12 inches on bottom.
Yes, so 12 inches goes down here, because again, I'd use my units to guide me, and then 1 foot on top. Okay. So now I'm done. I know I'm done because my unknown units of feet are here on top. So my setup should be correct, as long as I, did my numbers in the right spot. So now in my calculator for this one, I would do 250.4, and then I'm going to do divided by 2.54, because this number is on the bottom, and then I would divide by 12, because they're both on the bottom. So this one, both of them are division because they're both in the denominator. The ones on top, multiplying by those 2 ones will not change, so I'm not going to type that in my calculator. So 250.4, and then I divide by 2.54, and then divide that by 12.
Why isn't it multiplying again?
Say it again.
Why is it not multiplying again?
It's not multiplying because, so you have to kind of think of these as that's like it's a big fraction, and this number is in the denominator. And so remember in the fraction, when you write division in like fraction form, the denominator you're always dividing by, the top, the numerator you would always multiply by. So in this one, technically we are multiplying, we're just multiplying by ones, and they don't change the number of our answer. So really, I mean, if I wrote everything out, it would be 250.4 times 1 divided by 2.54, and then times 1 divided by 12. But because the ones are on there, we don't really use them in the calculation because they don't change the value. So all I need to do in the calculator on this one is just division, because both of the numbers, 2.54 and 12, they're both on the bottom in the denominator of my setup. Okay, so 250.4 divided by 2.54 and then divided by 12. And I get 8.215223097. It keeps going. So when I round my answer, this is where you have to think back to the beginning of the year when we did sig figs. And so we'll kind of have to practice this some more. But look at your known, this number, 250.4, that has 4 significant figures. So my answer would need 4 significant figures. So 8 and then 215. So I would want to cut it off after that. And so I would have 8.215 inches. or feet, sorry, feet, not inches, feet. 8.25 feet, 215 feet. All right, let me to here. So this one right here that you're seeing on the screen in just a second, as soon as it loads. So these are, there we go. These are common conversion factors. So there's some for mass, some for volume, some for length. So common ones that we'll probably use a lot are this, like this first one, 1,000 grams is 1 kilogram. The other ones allow you to go from metric to the imperial system. So like ounces and pounds, that's what we measure here in America on the imperial system. So you can go from, ounces or pounds to grams or kilograms. And then these other two, ounces to pounds and pounds to tons, those are imperial conversions that we use here in America. On the volume, a lot of these are common, like, 4 quarts equals a gallon, 2 pints is a quart, 2 cups is a pint, 8 ounces is a cup, tablespoons to cup. These are all measurements that we use commonly in America. Milliliters to liters, that's a common one for the metric system for volume. And then going between milliliters and like ounces or cups, these first three go from the metric to the American system or the imperial system. And then over here, here's the length one that we just used with inches to centimeters. And then here are sort of the imperial ones, like inches to feet, feet to miles, yards to feet. Okay, the possible ones you could need. There are definitely a lot of other conversion factors. These are just some pretty common ones that you might find useful when you're doing things, along with the time conversions that we talked about already. So I'm going to stop and switch over to, because I want to talk about your assignment really quick. Actually, I do need to go back to that. So after you finish kind of going through your lesson and looking at the examples, because there are more examples on your lesson on Canvas. So I would definitely encourage you to go through those and do those that are on here after this one. So it kind of walks you through this one, talking about the height of a building in meters. And it walks you through how to identify the known and unknown, how to do the plan. So you have units over here that you would drag, like what's the order going to be of your conversion. Here are the conversion factors that might be useful to use. And then it's going to have you, there's actually another tutorial. It's online, it's interactive. So if you would like to do more practice problems, then definitely work through this. There's a tutorial part of it. And then there are these parts where you can practice doing one-step problems and you can practice doing multi-step problems, okay? So there's a lot of different ones on there. So it's going to tell you to go through and do the tutorial one, the learn. But then you can also, after that, do more one-step and multi-step practice on your own so that you get a better idea of it. The link is right here to go to it. And then it's going to have you go through the tutorial, and then here's the multi-step one where you can click and you can do some practice conversions that are multiple steps and things like that. And then for your assignment, you're actually going to be doing, this is your actual assignment. So you're going to do, I think there's 4 or 5 different conversions on here. So you're doing kind of an at-home lab. The first one's just your age. So you would write down, if you're 15 or 16, however many years, write your number of years here. And then it says how old are you in seconds if your current age is, and so you'll put your age here again in years. And then here are some possible conversion factors. So your known is going to be however many years. Your unknown is going to be question mark seconds. And so your plan should match that. And then I've already kind of given you the dimensional analysis bars, and you can simply type in your numbers and your units here in the setup, and then you can type your final answer down here underneath with your numbers and units for the answer. Okay. The second one.
I highlighted green.
Do what?
I highlighted green, the answer.
Oh, okay. That's good. Thank you. Yeah, that's helpful if y'all want to highlight the final answer too, or do it in a different color or something. So the second one has to do with chewing candy. So if you don't have a piece of chewy candy, like, like a Starburst or a Tootsie Roll or even a Skittle, Skittles are kind of chewy after you kind of get through the first bite of them. Gummy bear, any kind of chewy substance you could use from this. Doesn't necessarily have to be candy. If you have like some chewy vitamins, like take one of those chewy vitamins or something like that. But something that's chewy. And what you're going to do is you're going to get the approximate mass of it. So you should be able to find that on like the label of the bottle or the wrapper or the bag. If you can't, try looking online for what it is and see if you can find it like on the website for the company. But you'll have the grams, the mass, and then you're going to record. So you can use the timer on your phone. How long does it take you to chew it until it's completely gone in seconds? And you're going to record that as a conversion factor because it took you that many seconds to chew that many grams. Because so those two things are technically equal to each other. And then you're going to talk about how many minutes would it take you to chew 1 kilogram of that same chewy candy. And so I've given you some conversion factors for mass and time, and then you'll rewrite again your conversion factor that you got from timing yourself chewing here. And so I've kind of given you some help down here on the setup because it has this weird conversion factor where you're going to go from grams to seconds. That's where you're using the timer that you timed yourself. Okay. And then the last one, I think this is the last one. Nope, there's two more. The third one's walking. So you'll time in seconds that on your phone. You can use your phone timer, how long it takes you to walk 10 meters. So if you have a measuring tape or something, that would be the most beneficial thing to use to measure out 10 meters. If you don't, then you can use your feet. So shoe size is usually in inches. So if you're like a size 10 shoe, that's approximately 10 inches. But if you do that, you'd have to kind of convert. That's a little bit more tricky. If you have an iPhone, you can use the Measure app that already comes on your phone to measure out 10 meters. Just make sure you change the settings from imperial to metric because it's set to do our American units. If you have an Android, there's an app called Measure that you can download. That should be by Google. It's missing the G. And it's the exact same thing. And here's a little tutorial for the Android one if you're not sure how to download it and use it. And so it says, how many hours will it take you to walk to visit the Empire State Building that's this distance away if it takes you this many seconds to walk 10 meters? So I've given you some conversion factors. The last one is the one that you are going to time yourself. So you'll have to put in your seconds here because everybody walks at different paces. So your known is going to be this distance, 1,571 miles. Your unknown is going to be ? hours. And you're going to have to convert using that. And I'm kind of giving you some help here on the plan again. Okay. The last one's typing. So you're going to time yourself typing these 38 words in this paragraph here. And that'll tell you how many words per second you type. And then you're going to use your conversion factors, identify your known and unknown, and set up because you're going to calculate how many hours would it take you to type the 76,944 words in the book Harry Potter and the Chamber of Secrets, considering how many seconds it took you to type the 38 words here on this little sentence or 2 sentences. Okay. So you have 4 different conversion factors or dimensional analysis problems where you're going to have to do your known, unknown, and plan, identify your conversion factors, set up your boxes with the numbers and units canceling out, and then you will type your final answer kind of after your setup, okay, for each one. Any questions on that assignment before I let you guys go? Because we're over time. Sorry, guys.
What if we don't have a chewy thing?
If you have a friend in class that does, maybe use their number. Or I can actually, I don't think I have anything to, oh no, I do have some chewy gummies here at school. I can time myself and I can send y'all my number and you can just use mine.
Okay.
Okay, I'll send you mine, Ariel, later today.
All right.
Okay.